All right, welcome back, everybody. We're continuing our look at Chapter 3, all about writing classes. The good news is in 3.1, we did most of the work. Okay, we took a look at kind of the big overall picture of what it takes to write a class, what's involved with that. What we're going to do with the rest of the chapter is just add some of the finer points, some of the final details to it in each section. Today in 3.2, we're talking about static members. Okay, now we've dealt with that static keyword before. Let's take a look at here what's going to be involved in actually adding it to our classes. All right, so the static keyword. We're going to say in Java, anytime you come across static, static just means one. Okay, static is a reserved word used to designate something belongs to a class. Okay, so in a minute we're going to give you an example of an object that has both instance variables, which will belong to the individual objects, as well as a static variable that belongs to the class. Okay, so in that class, all objects share the same static variables and methods, and then also static variables and methods exist even if no object has been instantiated yet. Okay, so again, static overall means belongs to the class, not the individual object. So let's take a look at a simple class that involves some static members. Okay, let's say we have the car class, and it stores information about a car, such as the type as a string and the number of miles it's driven as an int. Okay, these are both instance variables that will belong to each individual car we create. Anytime I create a car, it's going to have a type and miles. Okay, but then I have this static variable, okay, int numCars. This is a variable that's going to belong to the class as a whole. And when you take a look at how this variable is implemented, notice in my constructor I've got numCars plus plus. In other words, what this variable is doing is it's going to count up one every time a car object is created. Okay, so it's a counter variable for the class. Okay, I also have some methods for the object. Okay, here I can get the type and get the miles for that specific car object. But then I've also has a static method here. And what does this method do? It prints numCars. Okay, so basically what I have is a method that's not tied to a specific car, but again, it's the class as a whole. All right, that's the idea of static members, static variables, static methods. They work on the class, not on the individual object. So going through both those parts in more detail here, we have the static variable, numCars. Again, this is a counter variable essentially that gets counted up by one every time we call our constructor. Okay, so it's going to keep track of how many car objects have been created. And again, the way it works, all instantiations, there we go, so all objects, okay, of an object share the same static variable. Okay, we'll show you that live in a coding demonstration in a minute, but each individual car is going to have a different type and miles, but they'll all share the same number of cars. Okay, this is great for keeping track of totals, great for counting up. We'll show you through the lab some different examples of when you'd want to use something like this. All right, and our class also had a static method, so you can have static variables and static methods. Okay, the word static before the return type of the method means the method can be allowed to be called without an object instantiation. Okay, so again, this is a method that can be called without an object. It's called on the class. And when I go to call it, there's two ways to call it. I can call it directly on the class itself. So in my runner code, I could say car as in car class dot print numCars. Okay, or if I have a specific car object like car1, we can say car1 dot print numCars, and we get the same result. Okay, because again, the class shares that method, and what's that method using? A variable specific to the class, a static variable. All right, so let's jump over to CodeBoard here and just look at that code from the lesson in action. Okay, so I'm on the 3.2 coding demonstration from Moodle. Now I've got my car class here with, again, our static variable numCars as well as our static method. Okay, so if I go over to my car runner here, I've got my car class, and I don't actually even have to create a car before I can start using that static method. If I go car with a capital C, as in the car class, and then call that static method, I'm just going to check what it was again here quick, print numCars. I should be able to compile that. and run it. And it gives me total cars is 0, okay, because I haven't created an object yet. Again, how our constructor's working is on the class definition, numCar starts at 0, and then every time I construct a car object, that numCar should go up by 1. Okay, so let's make some cars. Let's say car C1 equals new car, and we want a string for the name or the type, and then in for the miles. Let's say we've got a van with 100,000 miles on it. All right, let's go car C2 equals new car. Say we have a truck with 50,000 miles. And then car C3 equals new car Slugbug with, let's say, 30,000 miles. All right, so I've got some car objects. And now when I call car.print num cars, I should get a 3. Compile, then run. There we go. All right, wake up. So I get the 0 for the initial car count, and then again in my constructor, every time I create a car, we're counting that up by 1. So we have up by 1, 1, 1. That's where we're getting the total cars is 3 there. Okay. Now again, that numCars belongs to the class, not an individual car. These individual cars still have instance variables. Okay, as in the type and the miles. So I can do something like system.out.println C1.getMiles. I think that's what this method was called. Get miles. Yep, good. And I can do the same thing for C2 and C3. We'll switch those to 3s and 2s. Yep, so each of those instance variables, each of those objects are storing their own instance variables. Okay, but if I do something like C1 dot print numCars, and C2.print numCars and C3.print numCars, I should get the same thing for all of those. Yep, again, because they're all storing that same numCar instance variable, that class variable, and essentially all calling the exact same method, that class method, the print numCars. All right, so there you go. That's how our static members, the static variables, and static methods work within classes. Okay, homework, you're going to have a few assignments where you have to write classes with static variables and methods. Okay, so start working on that. Start cranking out some code. Start writing some programs. And like usual, make sure you're reaching out if you need help.